Good afternoon and a very warm welcome to everyone for the today's webinar. On Stratasys F770, the large-scale 3D printing solutions from Stratasys. I once again welcome everyone for the today's webinar. This webinar will be presented by Mr. Ganesh Babu, who is our National Manager Additive Manufacturing, who sits in our Bangalore office. Ganesh Babu, to brief you about Ganesh sir is graduated from Bangalore from an Indo-Danish tool room in 1991. So, with 27 years of association within the Indian industry, he has held various positions and has been associated with additive manufacturing for well over 2 decades. He has the distinction of being the first Indian to extensively work on the resin-based additive manufacturing technology. So, he has held various positions such as senior tool room manager for Videocon and other Indian MNC companies. He has set up tool rooms and additive manufacturing departments for multiple organizations. So this was about Ganesh sir. To tell you about more about this GoToWebinar tool, so as of now everybody will be on mute mode as we want to have an one-side conversation. If you have any questions, any queries, there is an option to raise your hand and there is an option in the chat box window where you can type your questions. We will take the question and answers at the end of the webinar. So if you have any queries, you can either raise your hand or either you can type your questions in the chat box window. Also, there are few videos in this presentation. To have the best audio quality, I request everyone to kindly use your headsets for better audio quality. So over to you, Ganesh sir. Please take it ahead.
Well, thank you, Pranjal, for the introduction and a very good afternoon to all of you. And I welcome all of you for today's session on Stratasys F770, the large-scale 3D printing solution. So primarily, we at Designtech, we are the platinum partners of Stratasys. I will take you through with more details in terms about our business association and the product line that Stratasys offers for additive manufacturing. So, well, I'm based out of Bangalore and I take care of application engineering for additive manufacturing at Designtech Systems. So today I have the privilege of presenting to you all on Stratasys F770. Now the versatility of the F770 is something where for large scale 3D printing, here you have a solution with the industrial outputs. We talk about manufacturing or using additive manufacturing for manufacturing applications at an industrial scale level. So that is where we are going to focus on. So in today's session, like what are we going to take a look at? That's exactly where I'm going to talk about on the F770. But well, before getting into it, let me have a brief agenda presenting to you. Additive manufacturing or 3D printing, a brief introduction with Stratasys technology, because Stratasys today offers multiple solutions in additive. So a brief introduction into various technologies from Stratasys, and the focus is going to be on Stratasys F770, the large-scale 3D printing solution. We'll have an intro as well as the customer case studies that goes on. So you have the product specs, you have customers speaking on the product line of F770 for large part prototyping to manufacturing applications. So the core over here is to understand you're not going to compromise when we talk about making large 3D printed parts. We're going to talk about Stratasys quality, Stratasys accuracies in terms about realizing the benefits of having a large part manufactured, considering both time as well as cost. So let's get into it. But for those of you, let me also reiterate additive manufacturing as we add layer upon layer to realize any complex geometries, unlike the subtractive manufacturing, where we remove undesired stock to get into the shape what we desire. But let me also reiterate over here, the subtractive manufacturing has to have a design for manufacturing, unlike the additive. In additive, irrespective of what the complexity is, as it is a layer by layer bonding methodology to achieve complex 3D printed geometries, it is at ease you will be able to achieve the most complex geometries without any limiting factor for manufacturing. That's where additive plays a very important role. And more importantly today, while we look at Stratasys for well over 3+ decades is the 3D printing solutions company that the world looks over. So while we talk about additive solutions from Stratasys, I need to take you through over the last 3+ decades of Stratasys. They have been the first choice polymer-based 3D printing solutions provider. So well, worldwide, 140K largest installation base that you could see worldwide. And more importantly, when we're looking at a double-digit share of polymer 3D printing market, it has to be Stratasys, the pioneers who had invented the FDM technology. And while we look at multiple technologies, we'll take a more closer look in the coming slides of the 5 technology offerings from Stratasys. And we also have the associative software that goes along with the 3D printers. And they have been today ideally very well suited to read a native CAD platform. No more looking back at only using an STL file. Here we talk about using your native CAD data, limiting loss of data, or having a direct interface to your native CAD output that could be read by GrabCAD Print as a software. Well, for exclusive technologies that Stratasys offers, or for materials that come along with these technologies, the industry majors such as BASF Plastic, Enkel, SABIC, DSM, Avionics, and there are many, many more who are associated in developing materials for the additive technologies that Stratasys offers. So where are these technologies used? Across design, manufacturing, and more importantly, today we also look at healthcare, the medical world, as exclusive materials. Today we have systems exclusively built that could print anatomies, that would replicate a human anatomy very close to whatever the live anatomy is all about. So the core over here is Stratasys for the last 3+ decades have been innovating and reinventing the wheel of additive manufacturing. So when we talk about 3 decades of innovation, there is a never-ending innovative thought that keeps going on because there are newer materials, newer systems that have been very well adapted over the years for the industrial needs. That makes Stratasys the world's most widely used 3D printer. Stratasys 3D printers are very largely used all across the globe. So where do the machines get manufactured? They are manufactured at Rehovot of Israel and Eden Prairie in Minnesota in the US. However, there are also today component manufacturing, other subsystem manufacturing at 4 manufacturing locations. Plus the operations worldwide are 13 countries of operations, and there are multiple resellers or value-added resellers or partners who are carrying the Stratasys product line to customers like you. Here's the introductory video on Stratasys.
Stratasys is shaping the world around us. From 3D printed rapid prototypes and design freedom, to manufacturing innovation and production-ready solutions. We believe that what starts with a spark of an idea can now become reality. We see opportunities all around. The products, solutions, and services being developed within our walls today are changing the way things will be imagined, designed, and made tomorrow. Stratasys 3D printing solutions allows us to tap into the unlimited imagination and potential within each of us, helping designers, engineers, and manufacturers transform their capabilities and accelerate their progress across virtually every industry. Stratasys is shaping young hearts, planes with purpose, helping explore the next frontier, accelerating progress, manufacturing earth-friendly efficient designs, and delivering power and energy to the world. Stratasys empowers the dreamers to dream, inventors to invent, doctors to heal, and industry to grow. We are shaping innovation, creativity, discovery, education, imagination, and the possibilities of tomorrow. Stratasys, the 3D printing solutions company.
So well, in the video you would have taken note of various verticals or various industry verticals that have been covered by Stratasys additive manufacturing. But before that, as I mentioned, Stratasys are the people who invented the additive industry. Now, while we talk about additive industry, it is an association. Stratasys have been partners from start to finish. It is an association with users. It's an association with people who are looking at additive for what their exclusive, customized end-use requirements are, based on which these are platforms that have been developed, the materials that have been developed. It is to provide end-to-end solution. That's exactly where it all starts, and it keeps continuing until the customer's needs are addressed. So from start to finish, when you look at a partner like Stratasys, the systems are very well known to be well established and used all across the globe for industrial grade of 3D printing. So while we look at why Stratasys 3D printing, the experience means it's quite a lot. Understanding the need of customers, understanding the challenges in the product development world. Every customer has a specific need. Can it be a product that comes out from Stratasys? Can it address all the solutions? Can it handle all the materials? There are various questions to be answered. So understanding the needs and exclusively creating additive manufacturing systems that could be well utilized all across boundaries. Here we go. In India, our presence is more than 22 plus years. Stratasys have been present in India for 22 plus years, over 850 plus customers, 1,200 plus installations in India. So well, there have been education, automotive, healthcare, consumer products, and we also have aerospace and defense. So these are some of the names under each vertical which have been listed and who are Stratasys and our proud customers who till today have been working on systems for more than 1.5 plus decades continuously. Systems that have been installed at their bases are still running strong and steady. Here we go to talk about what is that Stratasys offers when we look at additive manufacturing. So most of you would be knowing that additive as a technology, in general, if you're looking at, it's a layer by layer print process, adding material to realize a physical output from a digital file. However, when we are going to categorize the platforms, the technology platforms from Stratasys, we have to look at, on the left, you have PolyJet, and we have stereolithography. We have Origin P3, we have SAF, and we also have industrial FDM. Now, what are these classifications of technologies are for? If I have to give you a brief, PolyJet, as the name suggests, it is a jetting principle of using a liquid-based material called as resin. Well, poly is multiple materials that could be simultaneously processed while jetting on the print bed. when we are going to jet materials, multiple materials, you will have a lot of finer details captured, multicolors. While I use the term multicolors, we have close to around 2000 different Pantone shades that could be printed with reference to the Pantone shade card. Multi-material, rigid, clear, rubber-like, and a whole lot. You'll have textures, you'll have products that you can print as an end-use part, what the designer intends with the textures, the logos, the text. All these are captured with colors as a final product. That's the PolyJet solution for you, whether it's single material or multi-material combinations. More importantly, when it comes to medical modeling of printing anatomies, it is ideally the best suited. With colors and multi-materials, you'll be able to print anatomies, medical devices, and quite a lot. Well, stereolithography has been there for quite some time. The industry is well aware of SLA. Now, the Stratasys SLA, the RPS Neo systems, could prototype from a single resin, a vat of resin, which allows the user to create parts with finer details and then with better clarity, highly accurate parts. It's all industrial grade of resins that are best suited to go with stereolithography. And Origin P3 to introduce is a DLP process, a digital light processing process. Manufacturing tools, or you'll be able to print parts in batches. It's a production process. More than associated with additive, DLP system from Stratasys Origin P3 provides you unmatched accuracies. And more importantly, injection molded surface finish. Materials that have flame, smoke, toxicity certifications, highly durable, that could perform on a product for their life. Small, critical parts in thousands could be manufactured using the DLP platform. An introduction to SAF, selective absorption fusion, is a powder bed fusion technology where PA11 and PA12 polyamide, nylon-based, powder-based materials are used. And again, it is a volume production machine. We talk about intricate as well as highly accurate powder bed fusion technology from Stratasys called as SAF. But industrial FDM, well, it takes back to memories over 3+ decades now that the patented technology which was introduced by Stratasys for extruding industrial grade thermoplastics. Ideally, when the technology got introduced, ABS was a material. And more importantly, Stratasys introduced to the world the fused deposition modeling. When we look at cost-effective outputs, and more importantly, highly complex and durable parts that could be used for high-end manufacturing, the best suited is industrial FDM. And today's F770 is under the FDM banner, the large-scale 3D printing solution with the FDM technology. So Stratasys, the 3D printing solutions company, in the slide you can see that these are some of the verticals that have been actually covered in this particular slide. Moving beyond this, you can imagine all that what you can digitally design for any given manufacturing vertical or design vertical. Stratasys technologies could complement to meet any of the challenges that are there in your design or manufacturing area. That's exactly where Stratasys supports. So again, Eden Prairie and Israel have been the dual headquarters where the manufacturing happens of the additive manufacturing technologies. Now, Stratasys innovation for the digital factory, while we talk about what is Stratasys innovation for the digital factory is the focus on. And now let's look at Deep applications, that is exactly where we are going to talk about. Deep applications, specific specialization, and more importantly, Stratasys, as I mentioned, is an industry in motion, moving beyond the general platforms. All across the world, you would have seen that today additive manufacturing is very well known to 3D print parts, and these are generalized platforms. And more importantly, while we look at various verticals that have adopted Stratasys, a small little elaboration to what we had discussed. Here you get to see all that pops out are the different verticals wherein Stratasys technologies have been very widely used, starting from aerospace, going up to industrial and heavy equipment or entertainment. You can name it, education, architecture, the medical world, as well as the dental applications. And it's more and more adding on because it's a never-ending saga when you're using additive manufacturing for your requirements to realize a physical model by cutting time and cost. So this is to reiterate that today when you look at polymer-based solutions, Stratasys has 5 leading additive technology platforms. Yes. And now let's focus more on these 5 leading additive manufacturing technologies. Each have their unique USPs. When it comes to design, the jetting principle enables you to achieve all that what you intend to design. It is not merely a physical output as a design, but more importantly to complement your design ideas as a final product. When you're looking at the end product, that's exactly where the jetting technology plays a very important role. For visual prototyping as well as for functional prototyping, we term the engineering grade of technology, whether it's going to be the jetting or the SLA principle. You have the engineering models that you can achieve. But manufacturing aids, the focus shifts onto FDM, the fused deposition modeling, as well as the digital light processing P3 technology. So while we talk about manufacturing aids, it's going to be the jigs and fixtures, the large parts productions. More importantly, it is not just one-off part. You can think about printing tens and hundreds of parts subjective to your requirement without having to invest in production tooling. So when you actually had to realize more on the production count, and when you have to have parts that you have to produce more in volumes of thousands, DLP supports, and in tens of thousands, the SAF technology or the powder bed fusion technology is the best fit for having volume production. Now let's look at what FDM technologies are all about. Here you have the robust, and these are machines that are made to perform over and over to give you repetitive quality, reliability as a factor, and more importantly, the proven Stratasys technology that stands by. So let me explain to you what FDM as a process is all about. The data what you design, it could be an exported STL extension or your step files or your native CAD data. You call it into the slicer or the GrabCAD print as a software, interface software. You process the files and submit it to the printer for printing. And remember, these are printers which go unattended. You don't need someone to man these machines. And finally, you print the part out. Dual tip extrusion is a principle. While we talk about dual tip extrusion, one tip is used for the material, so the model material, the model material, and the other tip is for the support material. Now I'll explain to you the model material and the support material. Both are in the form of filaments, and these filaments are driven by drive wheels into a liquefier zone of which has been contained in the build head, and the liquefier zone through which the nozzles are assembled gets the semi-molten industrial grade of thermoplastic to be extruded onto a build platform. Well, there are multiple layer thicknesses to talk about. I'll take you through more when I speak to you on these specifications of the F770. Now, more importantly, I want you all to take a look at what the F770 is all about, to elaborate more on the FDM principle, and more importantly, to give you more details in terms about the F770 as a product. So there you go. We talk about industrial scale simplified with the F770. Well, there have been quite a lot of highlights in the video that you would have been able to observe. The large build volume on the X, it is 1000 millimeters. On the Y and Z, it is 610. So it's the longest build volume with a fully heated chamber. The internal chamber is a fully heated chamber, which governs the output in terms of the quality with which you'll be able to print and use it at the next level. So while we talk about printing, we have 178, 254, or 330 microns. That's exactly where the conversion is. 0.007 or 0.178 of a millimeter, or 0.10 or 0, while we have to convert it is 0.254 of a millimeter. Very similarly, 0.13 of an inch, the decimal value, could get converted to a 0.33 millimeter layer thickness. So the choice is yours, depending upon the requirements and the features that have been there in the geometry. You can pick and choose what could be an ideal layer thickness. And you can also have adaptive slice sites, which means this is very, very exclusive. On a certain area, you want to have a larger thickness and a finer thickness. All those can be an adaptive process with the GrabCAD print. When we talk about easy to use, it's a user experience. Unlike to say that it has a user interface, which has a touch screen that allows users to just move the print across, if it is a small part, across a build platform, wherever you desire. And the printing happens on a build sheet. And there are 200 cubic inches of materials, both model and support. So over the weekend, if you have large print that needs to be submitted, yes, they keep going on with the continuous supply of power, uninterrupted power supply. The machine should keep going non-stop. But now the focus shifts to what are the 5 important issues when we talk about manufacturing. There are some of the important issues that have been listed. And when we consider today's manufacturing industries, let's take a look closely on the 5 important issues. Yes, most of us who have been in the subtractive world will be able to understand what the heading means: finding and retaining highly skilled labor. Today, it's all more on, rather than drafting and sketching or unskilled work, it's more importantly, the major challenge is getting to have a highly skilled person who could understand the functional expectations and be able to turn around using subtractive machines to realize parts and fabricate them to meet the industrial needs. So we all agree that finding skill sets is a big challenge. And while we look at maximizing automation in today's world, which means less labor, what is less labor and automation requires? You need to have systems that could meet all that. Whatever you want to maximize through automation, you should have systems that could take up and deliver what you need. And customer expectations on products are today expanding. They keep changing and the demand keeps growing. Designs have to be far superior. Product designs so needs quite a lot of iterations. Product design changes have to happen. And these are much in a shorter time span, and more importantly with frequent iterations, which ideally means to realize a physical part, you need to have a very good support in having additive systems that can give you durable parts. And what else? When we talk about software, data, and intellectual property protection, how do we really closely connect on this particular point? Yes, today, while we talk about connected manufacturing, they have to be efficient, and more importantly, we have to keep the data safe. And ideally, Stratasys systems are built for that. And what about the only constant that we talk about is change? Process changes, and more importantly, while we talk about process that change, we need to have tools that can allow us to be more flexible, that can be more quick, and it should be at random speed, that you will be able to achieve all that change that you need to have. So Stratasys talks about the benefits of industrial grade 3D printing. That's exactly where we are going to focus on, but customer driven needs for large parts, exclusive to large parts. While we are talking for prototyping or for jigs and fixtures, customers have a demand today. Can they be able to create large complex functional parts quickly and easily? The challenges, the subtractive manufacturing, the CNCs are not a single step solution. It's a multi-step process. Unlike the F770 as a large format printer with a single step on submission of the process data to the machine, you let go of the printer to go and complete the final layer before you have the physical part. But it is unlikely with subtractive manufacturing. Beyond the scope of manufacturing designs, you need to use various support tools, manufacturing tools, work holding devices, and it's a multi-step process, which takes skill sets, which is more laborious, and more importantly, it also takes quite a lot of cost and time. And more importantly, when we look at consistency and accuracy, when we take a polymer block and start machining, the factor of accuracy and the reliability between 1 and the 10th part will become a challenge. Reason being, there can be manufacturing tolerances. But when we are having a tighter tolerance with the 3D printing system from Stratasys, we are looking at achieving them with greater consistency, with the highest accuracies, and more importantly, with reliability. So ideally, when you look at solutions such as the competitive FFF technologies, etc., while I use the term FFF, it is form evaluation. What are these form, fit, and functional evaluation that we talk about? There are quite a lot of competitive technologies which uses FFF as a technology, fused filament fabrication for form, fitment, and functional evaluation. Ideally, the FFF technology doesn't equate to the industrial grade of Stratasys 3D printing. And that is where there is a big letdown. Companies who have invested on the FFF technologies are taken for a big ride. So existing technologies are unreliable as well as cost prohibitive. So starting from design, the F770, here we have a system that could reduce time. When it comes to multiples of weeks or months, we talk about narrowing those months to weeks and those weeks to days. That's exactly where the core is. With the ability, while we talk about what is the ability of the F770, we are looking at iterating a design. You'll be able to fabricate very quickly, and more importantly, if you have to iterate or intricate areas need to be cut and finished or realized with a different shape. The 3D printed parts are pliable, which means you can cut them, you can machine them, you can finish them. And all the functional refinements can be checked in the very first sample. This means you have a cost-effective solution, which is a great enabler for you to cut down on time, as well as easily have the best product to be designed with the very first prototype output that you can realize with the large format F770 FDM system from Stratasys. So here you look at one of the case studies here, we talk about one-piece large jigs and fixtures. Now, while we look at one-piece large circular jigs and fixtures, the point of accuracy becomes very critical. So achieving them in a single go with very minimal waste, while we talk about the support structure as soluble, it's a hands-free support removal. You can dissolve these supports in a water-based solution. Wherever you have one-piece fixtures, and when you have to have highest accuracies on those fixtures, you can print them out. It's hands-free, and more importantly, while we talk about large parts manufacturing, it lights out manufacturing. That's exactly where we are looking at. Quality, and more importantly, in-house cost. Data confidentiality is withheld. Here we go. Design freedom. When we have a creator, when we have the designer to create a data, the designer's mind can go to create the most complex designs. But we need to also take into account, if we are looking at subtractive processes like machining, we are looking at a design that can be manufactured. So the designer's ideas are constrained. He has to make a design that can be machined. But don't stop your ideas. Come out with your most critical, most challenging designs and get them realized, because you have the design freedom to work with Stratasys F770. Here again, take note that the soluble support gives you a unique hands-free solution to clean the undercut or the internal areas which have been covered with the soluble support material. So intricate geometries, more importantly, when you're looking at certain focus for having a single piece, highly complex design to be realized, here we go. You have a solution that can let you achieve it. And for the manufacturing, you can definitely simplify your designs, or you can have multiple split inserts that could aid your manufacturing line. But as of realizing the complex designs, the best fit today is to look at Stratasys F770. So proven technology, that's exactly where we are looking at. Why F770? It's a proven technology. More importantly, Stratasys are industry leading additive manufacturing manufacturers. World accepts Stratasys as a world's major additive manufacturing technology, and that's exactly where it is proven. Stratasys proven technology that keeps working over and over for multiples of years. For whatever the product line they have introduced, there are certain stringent tests that are being carried out, which qualifies the machines, and more importantly, their materials and the software that comes along. So while we talk about testing, here I have some numbers to present to you all. Plug and print. What does plug and print on the Stratasys FDM systems talk about today? 3D printers today are checked for system reliability, printer performance, and more importantly, Every individual component specific to its geometry is being tested. Component life has been tested. System life gets tested. And the final part, repeatability in terms about the geometry, its accuracies, its finish, all are taken into account. And more importantly, when it comes to the factor of functionalities, the strength of part is again tried and tested out. So the numbers over here talks about thousands of hours of system reliability. And then we are looking at, more importantly, live testing, controller software testing, and what more? Very different geometries, 4,600 different parts that have been printed out. And look at the number of cubic inches of materials that these systems are being tried and tested for before being launched into the market. 60,000 cubic inches. And the Forbes prediction also has to talk in terms about the digital transformation of the factory floor. The factory floor, which is already filled with subtracting machines associated with complementing technologies from Stratasys, such as the FDM 770, will definitely accelerate and, more importantly, enable digital transformation. And that's where Forbes have already given out for producing goods with the greatest digital transformation associating with the factory floor accelerates with Stratasys systems. So additive manufacturing is an enabler, and more importantly for supply chain efficiencies, because we all know that supply chain people are the ones who run around to source parts for various groups within an organization. But it's not easy. They have to identify, they have to look at multiple vendors, they have to look at their capabilities. Not each of these vendors have everything under one roof, and it becomes more complex. Time and cost are to be taken into consideration. How could you save cost as well as on time? And that's where we talk about a digital inventory. A digital inventory is something that you have a digital data. You can fire the digital print onto your system by owning a system in-house, which means that you don't have to have supply chain challenges. You don't have to run around and source. You have multiple materials on various Stratasys technologies that can offer subjective to your line of requirement. Now, Synergy talks about workflows, integrated tools, and customer success. That's where Synergy speaks about in terms about how the F770 is a large format printer at a lower price. Yes, believe me, it's an affordable printer when we look at in terms of its size and, more importantly, its performance for large format printing. So leading the market for reliability and repeatability have been proven not by one or a few. There are multiples of industry majors who talk about Stratasys reliability and repeatability for successfully producing large parts than any other additive manufacturing provider. That's where Stratasys stands for. Let us again look back at some of the key attributes to remind you all on the core F770 as the FDM technology for large format printing. We have strong functional parts. We talk about a fully heated chamber, which means in this internal chamber, it is subjective to the selection of what you do, whether you want to have a solid part which is fully dense, or you want to have sparse, or you want to have an hexagonal fill, or you want to have a sparse double dense. The choice is all yours. How would you like to have these printers? The printers can qualify to meet any of your selection process on the software. And more importantly, with the very large format, either you have large part printing, or you can also have a set of parts, a large as well as a few small parts, all nested together on the build platform to have the best possible print and the best throughput. So while we talk about, again, reiterating the proven Stratasys technology, it is an industry leader for large parts. It's proven, reliable, and more importantly, consistent and accurate technology. And what about the users? As I said, the user interface with the intuitive operation makes enablement to have variable slicing. More importantly, you can also have mobile monitoring. You can let the printer do its job and monitor from elsewhere, from your homes, from the comfort of your homes, or away from the factory floor to check on what's going on. So mobile monitoring. And with a single LED, you'll have multiple slices. That is more unique. And again, while we talk about the manufacturing floor ready, these are equipments that could come along with the MT Connect, which means that the recordings, the data of the printed part, along with the layer by layer recording in terms about the MT Connect, will give you access to address any challenges if you encounter and find out where the issues are. And more importantly, functional materials, industrial grades of ABS and ASA, and the exclusive Stratasys SR30 as a soluble support. With the large volume that the materials come along with, 200 cubic inches means you have unattended runs, as I mentioned, for large parts. Let the printer do its job with a continuous supply of power, and the materials are already loaded there for you, so you can start a print and forget it until it gets completed. So while we talk about technical innovations, there are very many for the F770 in comparison to the other Fruta systems. We have linear motors, GrabCAD print, and more importantly, we have a controlled heated build chamber, industrial connectivity, and more importantly, do understand that Stratasys knowledge and technology stands by you. So precise printing, when you're looking at CAD to print, all that happens in a single go. With the heated chamber, it's an enablement to achieve stronger parts and control over any curl up or any warpage during printing. And for solid and sparse print, all that gives enablement to have higher success rates for functional parts. So with the connectivity, you have communication from every angle, in person or remote. That's exactly where you score upon. So at a glance, when we are looking at customer pain points, when we are looking at with existing products, for those of whom there are printers with a triple F process, you'll have quite a lot of challenges because there are hidden costs. Productivity is hampered, quite a lot of maintenance and rework to be done. And the parts that get produced are not very highly accurate, and it's difficult to use. The answer lies with Stratasys F770 because we have consistency in the build and CAD to print fidelity. While we talk about CAD to print, as I mentioned, will be the native CAD files that can go on to the GrabCAD print, and without having to waste time or to have challenges with the file export. That is exactly where you are addressed with the CAD to print fidelity. Exporting of CAD geometries can result in data losses, which can be addressed here, and the ease of use, which means a quicker success, and more importantly, people who take care of printing can let the printer do its job and they can get started with the next level of work so that it is more uptime in terms of company efficiencies. Customer pain with existing printers, poor part quality, no service or support, jigsaw puzzles, assembling parts becomes a jigsaw puzzle because there's quite a lot of challenges. When you look at, you have large parts, you have quite a lot of challenges because there are thin and thick walls, there can be warpages, there can be quite a lot of challenges which comes with customer pain points today, even while machining parts or using a low-end 3D printer or competitive printers from other technologies other than Stratasys. But Stratasys proven parts can stand up to what has been designed and print within the limits that have been specified to answer to your needs. While we talk about service, this has been proven over the last 3.5 decades now. Stratasys has global service at all local levels. More importantly, accuracy when it comes. It answers to multi-section parts also, or if you want the largest part within a meter to be printed or a meter in size, all that has been done is no more joining, but you have large format printer to address to printing your large parts. Here's a customer case study from Sub-Zero on the F770. This is a video which is coming up.
Sub-Zero Group is a manufacturer of luxury appliances, Sub-Zero being a refrigeration appliance, Wolf being our cooking appliance, and Cove being our new dishwasher line. The corporate development lab basically is a mini factory. We're a factory within a factory. We have 7 3D printers. I really enjoy 3D printing. It's my one love in our lab. I can still turn the light on in that compartment and watch those things run and think, man, it's amazing what these things do. And they are really, really important to us. If you open up a refrigerator, for instance, we make those parts within our lab. Basically, we try to duplicate as many of the technologies and applications that we have in our production floors right within our lab. I was excited about the F770 because of the build size. What we're starting to see is a lot of parts that are just starting to fall outside the build envelope of my Fortis 400s. And so because of that, my Fortis 900 gets overloaded. And also because of that, we end up sending some more of our bigger parts now out to service bureaus. So when I heard about the build size of the F770 and also the price point that was being talked about, I thought, wow, this could be a really nice addition to our lab. The size, the 39 by 24 by 24 is a size that fits us very well. Big's always good. You can make small parts on a big machine, but you cannot make big parts in a small machine. The biggest thing with having the 770 in the lab is that we're going to be able to keep bigger parts in-house. So it's going to eliminate a little bit more outsourcing, probably 30–40% in savings for us to keep it in-house, which is huge. When you've got product builds coming basically every 6 weeks, 6 weeks, it seems like a long time, but it's not when you've got a large number of component parts that you have to generate, and you got to make sure that you have everything on site and ready to go when that start date is. So we can't miss a beat. Knowing the reliability that Stratasys has shown to us over the 20 years we've been printing with them, I have nothing but confidence that this F770 is going to perform equally as well. We have not seen any major downtime in any of the printers that we've had. They've been supported extremely well. They're made extremely well. I just look at that Fortis 900 that we have, and that thing's just solid, rock solid machine. And we run them hard. Those machines never shut off. We're in there Saturdays and Sundays changing them over because we need the machine time, we need the throughput. And so I don't know, I really don't know where we'd be without them. I did get an actual couple of requests this morning for some bigger parts, and I thought, okay, perfect. Those are going on that machine this afternoon.
So there you go. We have some of the users who talk about Stratasys product lines for printing large parts. So competitive parts, when they have been taken for certain production study and challenges, FFF parts have got various areas because they lack accuracy and precision. More importantly, when we talk about having the F770, which ideally means that printing a part close to 800 millimeters is not very easy. And as a single step solution with soluble support, you have the success. But when you're looking at other competition, other technology competition like selective laser sintering or stereolithography apparatus, you could see that where the bed size lies and with how many sections you need to print them. But ideally, when we are looking at the auto wood that the geometry is all about, here we are looking at F770. When we look at the cost in comparisons or the time in comparisons, it's much superior, and which gives the benefit of working with the F770 rather than even, because the CNC is not even applicable for a geometry like this, to be very honest. So you have to look at other additive processes, and in comparison to the Stratasys F900, still you have the cost comparison to be far more superior to the F770 than the other processes. And similarly, we have an injection molded large part. While we talk about, again, one huge part, highest complexities, and there are a lot of undercuts, not suitable for a CNC. There's a very complex geometry to be looked at. So molding will be taking multiples of weeks if you're going to outsource it. So what's the best solution? Today, F770 talks about the design freedom with soluble support. And more importantly, the difficult areas to machine, the internal channels are all achieved in a single print. Ideally, that's exactly where we talk about while we look at CNC as a multiple setup and more importantly, multiple work holding fixtures and a lot of operator time is required. Here the comparison talks how best it's a best fit in terms about having other competitive technologies as well as the subtractive CNC manufacturing where it is not an applicable process. And the triple up is again ruled out. Fused filament fabrication is ruled out. Reason being, there's a highly challenging geometry for their machines. They miserably fail to even realize a print. So when we look at more automotive applications, large prototypes, jigs and fixtures, tooling, soluble cores. Here we have the majors who talk about bumper printing and bumper texture printing. Now these are best fits because you have ASA as a material. More importantly, you have 8 different colors to talk about working with the F770. And here we have the car body, full car body, printed in sections though. However, this can happen only with the F770. More on the manufacturing line, yes, jigs and fixtures with an hybrid model or even sheet metal forming with an hybrid model for soft metals can be a best fit, or we talk about soft jaws for machining can ideally be a best fit for printing with the F770. So additive manufacturing produce tools. In order to summarize, we talk about tooling that has more complexity and then more importantly, consolidation of tooling components. That's where the core is. Weight reduction, easy customization, all that as a matter of fact gives enablement to achieve the best of results. So Stratasys stands by with their materials, with their repeatability in terms of quality, and more importantly, to integrate their additive manufacturing systems into any manufacturing floor or any factory, which means factory integration gives an advantage for elevating capabilities to advance the digital factory. A snapshot on some of the Fortune 500 companies when we look at the various big brand names from multiple industry verticals. So there we go. It's now time to take questions, and more importantly, you can also reach us at our various social media sites, LinkedIn, Twitter, Facebook, or YouTube, as well as get in contact to our marketing team or to the sales managers all across the country, where Design Tech has multiple offices all across. For all of you to join, do let us know how we can reach out to you. And now I'll let Pranjal to take over and check if there are any questions that needs to be taken up, and let's get into discussions now. Thank you.
Thank you, Ganesh sir. Thank you for your presentation. So as I mentioned earlier, you can either raise your hand or you can type your questions, and we can take it one by one. Also, I will be sharing the recording and the PPT on your email ID tomorrow. You can check that as well. Okay, sir. So to start with the question, sir, we have first question. Can the machine print any type of material like PP, ABS, PEEK, etc.?
Well, thank you for a very important question that you brought up, because primarily when we look at F770, here we have a printer that can work with ABS and ASA. So while we talk about ABS in black color and ASA in 8 different colors, but not polypropylene, because industries have the versatility to work with a various set of technical parameters, and ideally all that falls under the most widely used polymer under the family is ABS. So predominantly it is ABS and ASA. These are the 2 materials as of now, but probably since innovations are a continuous process in Stratasys, we may have certain new materials arriving that can go along on the F770. But as of now, it is ABS and ASA in 8 different colors.
Right. So Ganesh sir, so continuing for this question, also Mr. Akash wants to know, are the material open source or the machine only runs on OEM material? So I think he is also asking in general statuses along with F770. So we can tell him about F770 and other remaining printers. Actually, that is what he's are trying to ask.
Okay. So well, as of F770, here we have the printer that would be supported with Stratasys materials ideally. As I mentioned, as a patented technology, the FDM machines were very well controlled for what is expected, unlike the other FFF, which allows open source materials. But now, other than the F770, we have printers on the FDM technology platform itself, like the Fortis systems, that allows you to take up an open OML license. We talk about an open material license, which gives customers the flexibility to either work along with the open source material that they can procure and use it on the platform, or if there is a new material that needs to be developed, they can work along with the Stratasys R&D team for setting up the parameters or setting up the processing parameters on the machine that could be associated with the material that you wish to work with. So you have yes or no for this particular answer, because on the F770 it's a no, but on the other FDM systems, some of these systems we do have OML license. Like not just CFDM, we also have technologies such as the DLP process, Origin 1 P3, that allows you to work with OML license, the FDM technology with OML license, and so on. So we will be happy to hear from you more on this particular point. If as a user or as a prospect, we welcome you to reach out and we can have an offline, more detailed discussion on this particular point.
Right, sir. So we have next questions like what materials is used for a rubber, like as EPDM?
Come again. Sorry,
Yeah.
what material
So
used for rubber
what
like?
material used for rubber? In bracket, he has mentioned that like as EPDM. Mr. Saurav Kumar has asked this question.
Okay, Saurav, here we have an answer for you. Like on the F770, as I mentioned, two materials, that is ABS and ASA. We have platforms that could allow you to work with TPU. We don't have the injection molded EPDM grades,
Right.
right, for rubber. So we have
Right.
additive manufacturing technologies like we have the F123 systems, which allows you to work with TPU, thermoplastic urethane, with a Shore value of 92. Also, we have PolyJet, as I mentioned, the technology wherein you have the flexibility to work with Agilis as a material, because Agilis comes with Shore values of Shore 30. When combined digitally with other materials, you can go up to Shore 95. So there are Shore 8 to Shore 40, 50, 60, 70, and so on, 85 and 95 Shore values that can be achieved. But when we use the term EPDM as a final production grade of rubber, so today in 3D printing, you need to take into account, unlike the process of having a molten state of material flown into a metal die, here you don't use that. You have a direct printing process. So in FDM, it is semi-molten state, or ideally work with resins on the PolyJet technology to use UV light to cure them to achieve properties close to what your end product requirements are. And today, these digital materials on the PolyJet can also qualify to meet most stringent application needs.
Right, sir. Okay, so we have next question from Mr. Mohan. He's asking that is it possible to incorporate metal inserts like threaded bushes in LED electronic circuits made from sheet metals?
Well, thank you, Mohan, for coming up with one important application that the FDM technology from Stratasys is proud to talk about. We talk about embedding inserts, embedding RFID tags, your sheet metal connectors or components. Now, with special considerations, you'll be able to process the data, allowing placement of metal during printing, placement of inserts during printing, placement of electronics during printing or over molding during printing. All these are possibilities with these Stratasys technologies. Yes. Well,
Right, sir.
Pranjal,
Yes,
I
sir.
would like to read out Saurav Kumar's next question. If I
Yes,
have
sir. Yes,
answered
sir.
no one, then what
What
accuracy for making part for 3D printing? Now, today,
3D
while we talk
printing?
about, yeah, we talk about accuracies. We have accuracies industries look forward to. Today, we talk about anywhere accuracies between 50 to 100 microns. Yes,
Microns.
we have
Oh,
technologies to address. And when we are looking at FDM as a technology for 0.127 plus or minus, that is plus or minus 0.13 of a millimeter. Or in general, when you're looking at plus or minus zero point 0.2 for large format, it's a great fit to achieve such tighter accuracies. But with the resin-based technologies, we have tolerances that could enable you to achieve close to around 50 to 100 micron accuracies as well.
right, sir. So also we have one questions from Mr.
From Akash,
Vishwanath.
yeah.
Vishwanath, that do you have any training programs to work on your systems?
Well, as far as owning a printer, our customers are entitled to be trained, and it's a continuous engagement policy that we always work along with customers to train them, not just initially, but also there's a continuous training program that we have. We also associate with your teams on the applications and post-sales training that is being conducted. And more importantly, it's a continuous engagement policy. So for all our customers, we welcome training, and these are scheduled trainings to enable users to be independent and, more importantly, to better utilize the system for multiple applications. So yes, training is a part of the sales process,
Sales
but unlike,
process, right?
yeah.
Yes, yes. So also we have very first question, like can you give us some data about both the technologies that is apart from FDM like SAF? So in that case, how can we go ahead, sir?
So if there is a question which has been asked in some data, what technology that's apart from FDM and
SAF,
FDM, like
SAF, yeah.
FDM is a fused deposition modeling where we talk about using industrial grades of thermoplastics. While we talk about industrial grades of thermoplastics, these are materials that are identical to what the products that have been manufactured, whether it's an automotive or consumer goods. It can be anything for that matter. The ABS that we use are the same materials, industrial grades materials. Now, in the FDM technology, not alone the FDM, we have polycarbonate, we have got nylon grades, nylon 6, nylon 66, and nylon 12, carbon fiber filled, we have Ultem, and there are 16 different materials to talk about. But whereas when it comes to SAF, selective absorption fusion as a technology, here we are using nylon in powder form, PA11 and PA12. Now we are using PA11 and PA12 are two different grades of polyamides and in powder form, and it's exclusive to working on the powder bed fusion technologies. So predominantly when it comes to FDM, it is the same industrial grades of materials that are being used very widely. And there are 16 different materials to mention on the FDM process.
Right, sir. Also, if you could just read out the question from Mr. Mohan, like if we have any statistical analysis such as DO being carried out to validate the process robustness to match other time tester methods such as injection molding, which ensures the best molecular chain bonds using screw plasticizers. Also, with the continuation, like DO is means he means to say design of experiments.
Right. Now, Mohan, here we have a technology from Stratasys. Well, we talk about the materials, the testing processes, and the principles. These are all ASTM standard tested. Now, while I use the term ASTM standard tested, the printed outputs in various orientations are subjected to the most stringent tests, and the qualification criteria as to prove that they meet up to the ASTM standards in terms of what the qualification is, and the data sheets of each material for various applications have been tested and proven. And when it comes to injection molding, in comparison today while you're talking, so injection molding, in principle, you're looking at a molten metal being injected into a metal core and cavity, or injection molding tool. While you look at the molecular chain from a molten state to a semi-molten state, the properties may definitely differ. However, the functional equation is taken into account here. We take into consideration on the heat deflection temperature, the tensile stress, the elongation at break. There are various factors for different materials. Now, each material goes through all these qualifications of material testing, and the material testing itself on each of these materials has a whole lot of technical application guides worked along on the ASTM lines of testing, and you will have all this available to you specific to the material that you would like to use.
Right, sir. So we have next question, like what was the sheet used before printing the materials in F770 in the video which was been shown? So what was the sheet which was being used?
Well, these are exclusive to Stratasys manufacturing process. These are ideally plastic acrylic based sheets which are being held by vacuum on the build platform. Okay, so these are very thin sheets which are called as consumables. Now these sheets cover the entire build area, and vacuum suction holds the sheet onto the build table, and upon which the printing happens, which means that you can strip off post printing. As you could see in some of the videos, the parts being printed from the build sheet would be stripped off, and then the support structure, wherever accessible, you'll be able to peel it off, or then you can soak it in the Waterworks solution that allows, it's a soap like solution which dissolves the soluble support. So ideally, coming back to the point of printing the part on the F770 and on the Fortis systems, we have the build sheets. Now, while we talk about working with Fortis systems exclusive to printing Ultem or polyphenol sulfoam or high-end materials, we use a sheet which is capable to withhold higher temperatures. So similarly, when it comes to ABS, it's the generalized acrylic sheets exclusively developed for the F770 as well as for the Fortis systems. To the size of the bed, these are getting manufactured at standards, and these are consumables. But on the lower end systems like the F123, we have a build tray or a build platform, which is an injection molded base upon which directly the printing happens, and you will be able to peel off the printed part post printing. So let me reiterate here, when we talk about looking at a triple F technology or a low end 3D printer, ideally you don't have the internal chamber which gets heated, or the build table will get heated otherwise. And the build table, since it is getting heated, can have a certain condition to hold on to a few layers of the job. But when you're printing long 3D printed long Z-axis print, then you'll have a curl or a warp because the same heat cannot be transferred throughout the job. So here the patented technology works with vacuum suction that holds onto the build sheet and the entire chamber as a controlled temperature with which the printing process happens. And that governs the output in terms of qualifying them either to meet certain strength aspects or the functional aspects, or in comparison, there are certain geometries for an injection molded output, a direct comparison that can come as close as 80 to 85% of meeting most of the stringent functional qualities that the 3D printed part has to carry in there.
Right, sir. Yeah. I think he is also thanked, and he's thanking you to answer his questions are in a right way. And other questions, Mr. Arun Kumar, regarding any commercial part, I think I will take it offline. So other than the commercial questions, I think all the technical questions are being answered by Mr. Ganesh sir. So also, if you have any other questions, you can email us. We will take it with Ganesh sir, and we will revert you. And for all the other commercial questions, we will personally get to you. We'll connect with you, and we'll let you know about all the commercial part. So thank you everyone. Thank you Ganesh sir. Thank you for your presentation. So once again, thank you everyone for attending this webinar. Have a great evening. Thank you.
Oh, wonderful. Thank you, Pranjal, for organizing. And more importantly, I thank each and every attendee who has taken time to join us. And more importantly, this has been a wonderful session for me because there have been some very interesting questions. More importantly, been a continuous association in terms about getting to know from the beginning to the end of the webinar. There have been certain very interesting questions raised, what have been observed in the videos, all has been covered. I thank each and every one of you, and let us stay connected, and do let us know how we can reach out to you, to address most of your queries, and more importantly, also give you more details on the product lines for the interest for you and your industries. Do let us know. Until the next time we meet, I wish you all the very best. Take care till we meet again. Thank you and bye-bye.